This one is a problem for you to try, so pause the video, work through this one using the same approach that we've been using for the last few examples, and then when you've got your answer, let's restart the video and we'll go through the answer together. So for this answer, the first thing I want to do is find the prime factors. These numbers are on the large side, but that's okay. We'll just have some big trees. Here is my tree for 144. I chose to divide by 2 a few times, 2 and 72, and then 2 and 36. Then I chose at 36 to go 6 times 6. Your tree doesn't need to look exactly like mine, but we should all end up with the same list of prime factors, which would be 4 2s and 2 3s. And I just rewrote them down here just to kind of keep myself organized, basically. I have 2s and 3s sort of mixed together in my tree, so I'll put them in order, 4 2s and 2 3s. Next, 210. This was a fun one. Turns out that 210 has prime factors 2, 3, 5, and 7. First 4 prime factors, and each of them only shows up once. That's how we get to this number 210. Now, building the LCM, our thoughts are all these factors we'll have to use, but we go with where do we see the most. So thinking about 2s, it's over in this tree where we see the most 2s. 4 2s. Okay, 4 2s show up in the LCM. And then 3s, where do we see the most 3s? On this list we have 2 of them. This list has only 1, so again we're back to this list as having the most 3s. So we will need to also use 2 3s. 5, there's a 5 on this tree but no 5 here. So we'll use the 1 5 and the 1 7. And then multiplying these numbers all together leads to 5,040. Now I want to show you an example where we're finding an LCM of some expressions that include variables. Our approach is really going to be the same as what we've been doing so far, and I have a very smooth way of working in a new approach when we have to handle these variables. So let's start the same way. Of the prime factors of 32, and notice that I've just focused on the coefficient 32, and I'm not dealing with the x just yet. I'll go through my entire factor tree. So 2 times 16, there's the prime. 16 is 4 times 4, and each of those 4s will give us 2 2s. Now 32 has prime factors 2 times 2 times 2 times 2 times 2, 2 to the 5th power. There's where I'll use the x. So I'm going back and noticing I'm really working with a 32x. Now the x, we have to think of it like it's another prime factor. X, it stands for some number. We don't know what it is. It could actually be a prime number like 3. It could be a composite number like 6. It could be some rational number like 1/2 or a decimal like 1.3. We have no idea what it is, so we have to just work it like it is another prime factor. So I have it circled there. It's not on the tree. It didn't come from 32. It's that x. There it is circled, like so it looks like another prime factor. That's what I like to do with the variables. And we'll see how it works with the tree for 10xy. Start with 10. We've got our prime factors 2 and 5. And I'm going to list down here also, or on the side, 1x and 1y. We'll build our LCM the same way. Think about we have to use them all, so 2s and 5s and x's and y's. Where do we see the most 2s? Definitely on our first tree, we had 5 2s. Okay, next 5, we have just 1 5 right here. Now, think about x's. And remember, we're not thinking total, but where do we see the most? In this tree, we have 1x. In this side, we have 1x. So it's a tie, but if you think about where do we see the most, it would only be 1x. Here we see 1x. Here we see 1x. 1x is all we need in the LCM, because there's no place where we see 2x's. If it's in the LCM, 2x's, it means one of these lists has 2x's, and they don't. 1x, 1x, 1x. Okay, and let's not forget the y. So there's no y on this side. Here is a y. There's our y in the LCM. And if we multiply these together, the 2 to the 5th is 32 times 5 is 160, and 160 times x times y is 160xy. Okay, so this is my strategy for handling expressions with variables, and I want to just give you one quick example for you to try, but keep in mind that there are no big changes to our approach. If we do see variables, we'll just throw them in here like they are prime factors and build our LCM the exact same way we've been doing it so far. Here's your problem to work. Find the LCM of 44x squared and 33x. So please pause the video, work through this example, and then restart, and we'll go through the answer together. So here's my answer. I'm starting with factor trees to find the prime factors. From 44, I ended up with 2 times 2 times 11. Now this is an x squared, so I actually need 2 x's. You might not have thought about this is how we should handle x squared, but it is anytime we have an exponent on one of these variables. To really break it down like their prime factors would say, oh, an x squared, we know we can break that down to be x times x. It's a dead end here at x. There's no information about how to break down that number. But x squared is definitely telling us x times x. So I want to take that approach whenever we see some exponents on the variables. Next, 33 was a quick one. Prime factors just 3 and 11. There's only one x in that expression. And now I was ready to build the LCM. Thinking of 2's, here's where I saw the most. I had 2 2's and 1 3. 11, we had a similar kind of situation like we had in the last example with the x's. Here's 1 11. There's another 11, but we don't have a list that has 2 11's. This has 1, that has 1. Where we see the most, we only see 1 11. So 1 11 is all we need. But x's, we do have a place where we see 2 x's. Here's where we see the most. This has 1, this has 2, so we need to use 2. And finally, we'll multiply these numbers together, get our coefficient 132, and the 2 x's together for x squared, 132x squared.